Hello everyone, welcome to my unofficial talk at PyCon Portugal 2022. I was supposed to be presenting my Pydon'ts talk in the very first PyCon in Portugal, my home country, but sadly I had a family emergency and I couldn't make it. Everything is fine now, so don't worry. And I put a lot of effort and thought into my talk, so I thought I would share it with you anyways. So this is what I will be doing now. And just bear in mind that this is a slightly simplified version of my talk, because I was going to be doing a couple of things that I cannot do while recording on my computer. So before we jump straight into the good stuff, let me just give you a little bit of information about myself. My name is Rodrigo, and my formal education is in mathematics, so I'm not a computer scientist. But I've been writing Python code since 2012. And nowadays my involvement with Python comes mainly from teaching through my books and my workshops and my courses and the blog posts I write. So I really like teaching, and in particular I really like teaching Python, so I do that as often as possible. Also, I would like to invite you to check my work on Twitter. I use Twitter to share Python knowledge with others. I don't share pictures of my food there, because usually the stuff I eat isn't picture worthy. But yeah, if you're into Python content and you want small tips every day, just go check my profile on Twitter. Now, I want to tell you about a piece of code that finds the longest word in a list of words. So I'm going to go ahead and I'm going to open a notebook here, and I want to show you a piece of code that a beginner wrote. So they define a function that was called getLongest, and this function is supposed to find the longest word in a list of words. So they initialized a couple of auxiliary variables, and then they said that they were going to traverse the indices or all the legal indices in the list of words, and then they would check the length of the current word, right? And then they would see if the word length, so if the length of this word is greater than the length of the longest word so far, we need to update the longest word, and we need to update, obviously, the length of the longest word. So that's going to be word length, and then we return the longest word at the end. Now, to test this, I have a big file of words on me, and we want to read from this file, and we're going to take all of the words, and that's going to be, there's a word per line. So we're going to go through all of the lines, strip the white space, and then we're going to check what's the longest word in this list. And I've tested this a lot, so I know that this is the longest word. This is a word that has 28 characters, I think. Yeah, exactly. It's a very long word. I have no idea what it means. And just so you can check, there's, I don't know, the first 10 words in this list. So it's sorted alphabetically. Right, so this is the piece of code that the beginner wrote. And I think it's fairly easy to understand the code, right? You set the auxiliary variables that will keep track of the longest word we found so far. And then we go through the list of words. We pre-compute the length of the current word. And then we check if it's the longest word so far. And if so, we update the longest word we found so far. And this is straightforward, right? And what I claim is, even though this code is nice and it's very easy to understand, I claim that we can make it better. And so that's what we're going to be doing together. We're going to try to improve this piece of code. Now, the very first thing I think we can do is take a look at the for loop here. Now, notice how in the for loop we're going to pick the index. So we're going to iterate over the range of the length of the words, and we pick this index, and then what do we use the index for? To index into the list of words twice. That's the only thing the index is used for. In fact, we don't really need the index itself. What we care about really is the word that we're pointing at. So there's no need to iterate like this. Python has very nice for loops, and for loops, they can be used to go through lists directly. So we can perfectly say that we want to go through each word in the list of words, right? And then instead of picking a specific word with the index, we can just use the auxiliary variable. And so we don't need that. So we can write our for loop like this. In Python, any iterable can go in here, and you can go directly through those iterables, and lists are iterables. So if you have a list with items and you care about the items, just go through the list itself. There's no need to compute the length of the list and then the range of the length of the list to go through the index. Right? So this is another version of our function, and let's check it still works. And it feels like it still works. So there you have it. Our very first improvement was to write a for loop that goes over the list and not over a range of the length. So yes, the range of the length. Now that's one change we can make. Now the second thing I would like to argue in favor of is a quite interesting thing. And it's not a change in functionality of the code, it's just something semantic. Because code is written, right? Of course, code has to be written, but code is also read a lot. And so when you write code, you have to keep in mind the people that will read it later. It can be you in a couple of weeks from now, or in a couple of months from now, or in a couple of years from now, but it's also going to be other people. So as much information as you can put to make your code easier to read, and the better you can make it. What do I want to say? You want to make it easier to read, right? And that can be through nice comments, by naming your things correctly, but also by changing the layout of your code to make it easy to read. And in here, there's a semantic change you can make that will put across a very specific structure in your code. And that is these two variables here. They are associated, right? There's an association between these two. Because this is the longest word you found so far, and this is supposed to be the length of that word. And so these are two variables, they're two independent variables, you can assign them to whatever you want, but in practice, you use them together. Whenever you change one, you change the other. Because again, they should be coupled in some way. One contains a string, the other contains the length of that string. And so what you can do to make it just a little bit more clear that these two are coupled together, you can group the assignments, right? You can assign to these two variables at the exact same time. And again, this does not change the functionality of the code in any way whatsoever. But to me, this makes it extra clear that these two variables are related to one another. And likewise in here, because whenever you assign to one, you assign to the other. And by grouping the assignments, the reader gets the hint that these two variables go hand in hand. Now this obviously does not break the function, otherwise I wouldn't be showing you how to do this. Alright? Now, you must bear in mind that all of these things that we are going through, all of these suggested changes, all of these small refactorings, I claim that on average I will be showing you things that I think make the code better, but you have to bear in mind that readability is in the eye of the beholder, right? And readability depends on the context, it depends on the intended audience, depends on the average reader of your code. If this was code to show on a Introduction to Python workshop or something like that, I would stick to the very first version, right? I wouldn't be making all of these changes. Otherwise, if I'm talking to, I don't know, advanced users, the very first version would make them laugh, right? Because it was just very basic. Basic in the sense that it doesn't use other constructs to make the code more readable and more idiomatic. So you always have to bear in mind that better refactorings are better in some sense that depends on a context, right? So do bear that in mind as I keep showing other interesting features of Python and how they can be used in this function. So the next thing I want to do is argue again for a semantic change in our code. So the for loop here, this thing here, what's the point of this loop? The point of this for loop is to find the longest word. We want to look for it, right? And like the main logic of the loop is this thing right here. If the current word is longer, keep track of that. However, there's a line of code here that's distracting us from our goal, which is this one, because we have to compute the length of the current word. And so first we need to do this, and only then we can check if this word is longer. Now, obviously, what you could do is you could get rid of this, right? And you can just compute this twice. But I'm not a fan of doing too much work repeatedly, and computing the length twice, for some reason, I don't think is elegant. So another alternative is you can actually pre-compute all of the lengths, right? You can use a list comprehension, for example, to compute all of the lengths beforehand. And now, instead of going through each word all by itself, what you're going to do is you're going to use the built-in zip to pair up lengths and words, because now we have a list of words and we have a list of the respective lengths. So what you can do is, for each word and word length in the zip of the words and the lengths, and then the body of the loop is exactly the same. Now let's just make sure that this works. Okay, it feels like it does. So again, what's happening here? We are using the built-in zip to put together words and respective lengths. And I did that because I argue that the point of this loop is to look for the longest word. So the less stuff we have in here, the easier it is to see what's going on. Now, some might argue that this isn't great because now we have to go through the words twice. We are looping through the words once in here to compute all of the lengths, and then twice to search for the longest word. Yes, that can be bad, but also at the same time, if this is not performance critical code, going twice over a list isn't that bad. Now, what can be annoying is that this list comprehension here, this is computing a new list. This is building a new list of stuff. And if the list of words is very long, now instead of having a very long list, we have two very long lists. And the memory consumption, for example, we might not want to have two very long lists in memory. So there is a way to go about this. We can fix this, or we can work around this by doing something else. Instead of pre-computing all of the lengths in a list, what we can do is we can map the built-in length over the words. Now the idea here is that the map of the length of the words, this is not a list, this is something lazy that knows how to compute the length of each word, but does so on demand. So now we are going through the words and the corresponding lengths, one by one, and we do not have the memory overhead of pre-computing all of the lengths. And this obviously still works. And also, sometimes people ask me what's the point of map, because now we have list comprehensions. And to me, I think this is one of the typical places where map could still be nice. You know, it's just literally apply that function to all of those words. There's no point in writing a very long list comprehension just for this, in my opinion. Again, subjective, depends on context, on intended audience, but for me, I think this is a decent use of map. So this is where we are at right now. What can we do? Is there anything we could try? Is there any changes we could try to make? Are there any ways in which we can try to improve this? And actually, there's a trend of thought we could follow, we could explore. And I think it's nice if we can I show both of these at the same time. It's difficult to show both for some reason. Let's see, can I go? I can't. Okay, I'm going to erase this. Right. So there's these two versions here, and they're quite similar, right? The only change is where are we computing the lengths? But this, when I wrote this piece of code, this version of this function, it got me thinking. We are computing all of the lengths here, but we know as soon as we compute all of the lengths, we know immediately that there's one specific length that we care about, and that's going to be the length of the longest word, right? So, as we compute all of the lengths, we could immediately say, well, I don't care about all of these lengths, what I care about is the longest word, right? So, why don't I just compute the maximum length I have? Why don't I just compute the maximum length, and then instead of going through all of the words, comparing them one by one, why don't I just look for the word? So what's the word that has a max length? sorry, I was writing the code and for some reason I got very confused. I couldn't type and speak at the same time. So, sorry, the point was, we have all of these lengths, right? These are all of the lengths. But as soon as I'm working with all of the lengths, I know immediately that I can just focus on the largest of those values. So that's the maximum length. And if I know the maximum length, when I go through the words, I can ignore all of the words that do not have that length. And so I can just write a list comprehension, for example, that has all of the long words. So it has all of the words from the list of words that have a maximum length. And after I'm done computing that list, what I do is I can just return one of them. For example, the first one. Right? And this gives me the longest word. Assuming, obviously, we do not care about the fact that there might be multiple words with the same length. We've ignored that problem. We just want one of the longest ones. So this works neatly. And it's one way to go about the problem. Right? And if we want this approach, if we like this approach, then there's even something else we can do. And I really like this trick that I'm about to show you. And it's a trick, but it's not a trick in the bad sense. It's just an ingenious way of using a couple of built-ins. Because again, we're going through all of the words to find the maximum length. And then we're going through all of the words again to find all the words that are long. But as soon as we find the first one, that's enough for us. We only need one long word. We don't need plenty of long words. So there's a way to rewrite this such that it stops as soon as we find one of many long words. And let me show you. So we're going to delete this return and we're going to say that we're going to return, just for now, replace the brackets with parentheses. Now I'm going to call this function with all my words. And we see that the return is something that's called here a generator object. So this thing that used to be a list comprehension is now a generator expression that returns a generator object. And this generator is something that knows how to go through the words and look for long words, but it doesn't compute all of them immediately. It's not greedy like a list. A list comprehension builds the list entirely. A generator is like a map. It's something that knows how to compute its values, but it only computes them on demand. And in particular, we only need to demand for the first item of this generator. We don't need everything. We just need the first one. And so, obviously we don't want to return the generator. What we want is to return the next value of the generator. And the built-in next can take a generator and return its very first value, or its next value, which in the beginning is the first one. So we can just use our getLongest, and the next value of the generator is going to be this very long word. Because again, we only need the first one. And by using the next, this will not go through all of the words if we find a long word first. For example, this long word here starts with an E. So we did not go over the words with F, G, H, I, J, etc. because we only asked for the first value with next. And so, to me, this is an interesting way of going about this problem, of finding the longest word in a list of words. But this was just a sidetrack that I thought was interesting because it shifted slightly the way we are approaching the problem, in the sense that now we are computing first the maximum length and then filtering words. But this, together with the things we were doing previously, actually shows that we were very close to a very neat solution. We just need to pay attention to what we're doing. So let me go back slightly. Let's go back to the version with zip. Right? We have this version right here. Now what I want to show you is what this zip really is. Because now, sorry, not now. In here, we were going through the zip and then we were using unpacking to work with the word and the word length that was coming out of zip. But what I want to show you is that zip, this is also something similar to a map and to a generator. It's something that knows how to compute its values, but it's not a list. And it's something that you can use next on, and you can see that you get tuples with words and lengths. Why words and lengths? Because that's what we use to build Z, words and lengths. And C, you're getting tuples, right? Now what's interesting about tuples is that tuples can also be ordered. And in particular, let me do something else. Let me take this tuple right here, sorry, this definition of zip, and let me swap this around. Let me start by computing the lengths, and then have the words there. Now let's compute a bunch of some of the first values, right? And I want to get something, yeah, this works. Now, let me take this tuple and compare it with this tuple. Now, is this tuple smaller than this tuple? Yes, it is, because to compare tuples, what you do is you first compare the very first element. And in this case, 5 is smaller than 6, then this automatically says that this tuple is smaller than this one. Because we are comparing by the first element. And if the first element is tied, then it would break the tie with the second element. And if the second element was tied, then it would break the tie with the third element if there was one, etc. So tuples in Python can be ordered. But if tuples can be ordered, then in essence what we want to do is to find the largest of these tuples, because we want to find a tuple with the largest length. So instead of, I want to copy that again. Instead of doing all that work, what we can do is say, well, my function getLongest is going to take a bunch of words, and what it does is it's going to return the max tuple. So it's going to find the largest tuple here, the one with the largest length, and it's going to return it. Now, obviously this is slightly incorrect because we are returning the whole tuple, so we can just index into it. And now we return the longest word. This works. Maybe you won't like it as much, because maybe you don't like the way tuples are ordered. I don't know, but this is standard behavior, right? The way tuples are ordered is standard behavior. It's built-in behavior, and it's there to be used. And I actually like this. I actually like this solution. What I don't like here a lot is the fact that I'm calling max and then I'm indexing into it, because this is fairly easy to miss. So typically what I would do is I would write this in a slightly different way. I would say that I would unpack the tuple actually. So I'm gonna find the maximum of these tuples, and then I just return the longest. So this is a tuple, right? This evaluates to a tuple, and in here I'm indexing into it. Then instead of indexing, what I can do is I can unpack it, and I don't care about the length, so I can just ignore it, and the underscore says, well, it's a semantic cue that says I don't care about that value, and then the longest word is here, and then we return the longest word. So that's how this works. And now we are closing in on what I think is the best way in which you could write this function. Notice how we are building tuples with lengths and words, and then we find the largest tuple, and largest will be the tuple that has the largest element on the first index. But what this is doing is really another way of saying this in English is this is finding the maximum word by length. Or what we want to do is find what's the maximum worth if we use lengths to compare words, right? Because that's what we did. We paired the words with their lengths to use the length as a mechanism to induce an order. We ordered the words by length. And now this is just a matter of finding this out, and you can do that because someone taught you or because you read the documentation. The max function, the max built-in, takes an iterable and something that's a key. And this key, this argument here, this keyword argument, that's called key, accepts a function, and this function can determine the way in which you compare things. So instead of doing that zip dance, what you can say is return the maximum of the words, but compare them by length. So that's essentially what key does. If you have a mathematical background, this is kind of like an argmax. If you don't, you can ignore this remark. The idea is find the maximum of the words, but compare them by this key. What key? Length. And so that's what we do. We find the longest word. And I find this a very elegant solution. And I think it's a shame that I took so long to learn about this keyword argument here. Now this is absolutely gorgeous. This is very elegant. I find this a very elegant solution to this problem. And there's only one other change I would like to put forward, and that I would like for you to think about. And again, I know some will complain about the thing I'm about to show. Elegance and readability and the things you are willing to do depend on the context and the intended audience and the intended readers. But to me, there's something else we can do here. Let me zoom in for the extra, for it to be even more dramatic. So what's this function doing? This function takes an argument words, and the only thing it does is it has like this recipe here. It has the max, and this thing is fixed, right? This is there. It's set in stone. I'm not going to change this depending on the argument. No, this is already there. The only thing I'm going to do is take these words and put it in there, right? It's the only thing I'm doing. It's the only point of this function. And to me, the way to highlight this pattern of what I really want is, I want this to be fixed and I just want to put whatever words I get in there. To me, this should be written in another way. What I want to do is I want to go to the functools module and I want to import partial. And partial is a tool that lets you fix arguments to functions. So if this is fixed, what I can say is that the getLongest really is the partial application. This is really the partial application of max with key set to length. And now I can use getLongest and I can get the longest word. What did partial do? Partial took the words and put them in there. That's the only thing that partial did. It fixed this, it sets this in stone, and it lets me provide the remainder of the arguments to max. And this is maybe not a very well-known tool, I don't know. Maybe beginners don't need to know about partial, but if you're not a beginner, now you can go and read about partial and about the way this works. And to me, one of these two, this is, I would use, depending on context, if I were to implement a function like this, these are the implementations I would use, either one or the other. And I thought long and hard about this, and I think these are the best ways of implementing this function. If you disagree with me, feel free to reach out with a different solution, with a different proposal. I would be very interested in knowing what you come up with. So we've gone through a bunch of variations of a function that finds the longest word in a list of words. We started out with this, and we ended up with these two things. And before we recap all of the things we've gone through and all of the functionalities and features we've gone through, I just want to share another disclaimer with you, and that is, better refactorings do not necessarily mean less code. Alright, in this case, we ended up with less code because we just made use of the powerful max built-in because it has a very powerful, very useful keyword argument, but sometimes making code better actually means making it longer and making it occupy more space to convey the ideas better. That's fine. Okay? So the point of this talk is not write shorter code, the point of this talk is learn about the features that Python has to offer and try to make good use of them. Alright? Now, to recap all of the things that we've done, we've started out with this little function of ours. And the very first thing we did was we got rid, actually I think I'm going to use the pointer here. We got rid of this loop because the reason this loop works is exactly the same reason this loop works. And if what we really want is each word, there's no point in computing indices only to then fetch the words. Just fetch the words directly, because that's what we care about. And then the next thing we did was we actually grouped assignments of variables that are related to each other. We cannot have length updates automatically whenever we change longest, but we can group these two assignments to convey the idea that these two variables are strongly connected. So that was a semantic change mostly. And what we did next was try to simplify the body of the for loop. So the for loop is responsible for searching for the words. So let's just take care of the lengths first and then find the longest word. Let's focus on finding the longest word here, so let's compute the lengths first. But then this was a list, and we thought, well, maybe this might be, I don't know, taking up too much memory because we have to compute all of this up front. So instead, we use the map so that we will only compute the lengths on demand. And still we do have the loop focused on finding the longest word, but all of the lengths are taken care of before we go into the searching for the longest word. But then we were so focused on the lengths that we thought, what if we compute the maximum length first, right? We find the length of the longest word, and then just focus on the long words, you know? Just look for words that have the maximum length and then return one of those. And we could do that. And then we could even just return the very first one by using the built-in next and a generator expression. So the next and the generator expression, that's a really nice trick, a really nice recipe for finding the first element that does something. In this case, we found the very first word that has the maximum length. But then we figured that zip with the lengths and the words was already quite close to what we wanted, because tuples can be ordered in Python, and their ordering depends on comparisons of the respective indices. And so if we have the lengths first, we can order the tuples by the length. And so the maximum tuple in here would be the word, the tuple with the word, the tuple with the longest word and its length. And so then we index into the tuple to figure out what the word is. But essentially we use max to take care of the whole search. We don't need a for loop, we can just use max. But I said that honestly I don't really like the index over there because I tend to not notice there's an indexing operation there. And so what I like is I like to unpack things and then just return the longest word. And again, the underscore there is just a semantic clue that whatever's in there doesn't matter. So we put an underscore there so that users can focus on the longest here, that's what's being returned. And then all of this craziness, all of this going on here, the fact that we are zipping the lengths and the words so that the lengths induce an order, this could actually be taken care of by this keyword argument that the built-in max has. It's a very useful keyword argument that changes the way max works. So instead of finding the maximum word, it's going to find the maximum word by length. So it's going to use the length to determine what words should be considered the largest. And then I only argue that the fact that there's words in here, and that the words, I mean the actual argument. So the point of this function, the only thing that this is doing is taking this argument here and putting it in here, right? It's the only thing that's happening because this is fixed. And so what I said was, no, I don't want to close my presentation. No, stop. Oh my god. I want to show the next slide. Yeah, I just closed my presentation. Sorry about that. So the point of this function, the point of this definition was just to insert the arguments in the max. And so what we can do is we can actually use partial for that, because that's what partial does. Partial fixes this in the signature of max, and then we just provide the words. So these were all of the things we did. And I just hope you learned something from this. Well, all of these things, all of these changes, all of these features we talked about, zip, unpacking, the grouping of the variables, the maps, list comprehensions, generator expressions, next, all of that. So all of the references for these were these two books I wrote, or these two books I'm writing. Honestly, I don't think this book will ever be finished because there's too many Python features, so this just keeps on growing. And this teaches you how to use features of vanilla Python to write more elegant code. And then this book here is focused on list comprehensions, set and dictionary comprehensions, and generator expressions. And I'm just finishing the last chapter here and finishing the exercises. This has like over 200 exercises for you to practice. So these were the two books that I used as a reference for this talk. And I'm going to be sharing all of these links on Twitter and also on my newsletter. So if you want a weekly email with some Python knowledge, feel free to join. And I would love to hear your feedback. I love meeting folks, so just drop me a line. saying your name, saying that you watched my talk, and just give me your feedback. And if you found a better way of implementing the function that we looked at, also feel free to send it to me or tag me on Twitter. I would be very interested in knowing what you found, and I hope you enjoyed. Bye.